Class boundaries are numbers used to separate the classes so that there are no gaps in the frequency distribution. They would have an additional decimal place, so one more than the data. Typically, your class limits would have the same number of decimal places as your data, and then your class boundaries would have an additional decimal place. Class boundaries will end with the 0.5, or if there are more decimal places, it will be 0.005. There's a 5 at the ending. So in calculating this, you would take your lower class limit and subtract by 0.5. This is just an example. As I've said, it could be 0.005, but the key point is it ends with the 5. For the upper class boundary, you would add. So in our example, it would be for our first class, we have $80 up to $99. So by subtracting the 0.5 from our lower class limit, we would have a class boundary of $79.50 up to $99.50. And that was done by adding the 50 cents to the $99. In this case, we had whole numbers, so that's why it was just the 0.5. But had we had some additional decimal places, this would go out, those additional decimal places. This is just some additional information for you to be aware of. Typically these days, the graphs such as the histograms and the polygons are created using some form of software. And typically the software will take care of this for you. So the class boundaries were more relevant when graphs were made manually, but I want to ensure you understand the concept because we are dealing with numerical data, typically numerical continuous data, so there would be no gaps in that frequency distribution, and that's why it's an important concept to understand.